first humans stepped into Earth's orbit, engineers have been tirelessly working to improve these masterpieces of engineering. No, not that. I mean the spacesuits. And today, we're going deep into that evolution. From the 1980s to the daring future missions to the Moon and Mars, we're going to explore 5 key generations of spacesuits. Each one represents a massive leap in space thinking and engineering. So, buckle up. When you see the differences in capabilities across these 5 generations, you'll realize why the spacesuit is perhaps the most thrilling and vital piece of gear in our space exploration arsenal. This isn't just a history lesson, it's a look at the future that is being forged right now. Let's get started. In this video, we'll go from the bulky, heavy suits of the 80s to the smart, flexible armor designed for the future of the Moon and Mars. We'll uncover the secrets hidden within each generation and see how the minds of engineers moved from fearing survival in space to dreaming about settling on other planets. And the source links are also in the description. Here are the sections we'll be covering. A spacesuit is not just a baggy white balloon. The NASA EMU suit, the 1980s design that is still working. The NASA Z series, a conceptual suit lineup. The AxEMU suit for the new lunar surface mission. The SpaceX new EVA suit, a suit for space tourists. NASA's next-gen LEO suit, a collaboration with Collins Aerospace. In space, nothing is like it is on Earth. No air, no pressure, not even stable temperature. It is literally one step away from death. Without a spacesuit, an astronaut's blood would boil in seconds. Their lungs would rupture from the lack of pressure, and they would run out of oxygen to the brain before they even had a chance to take a last breath. The spacesuit is essentially a wearable, personalized spacecraft. Its layers block solar radiation, regulate body temperature, deliver oxygen, absorb carbon dioxide, and even allow an astronaut to walk in a complete vacuum as if they were strolling in their own backyard, except Earth is floating beneath their feet. Every spacesuit must perform these tasks flawlessly. The absolute vacuum of space causes body fluids, including blood, to immediately boil and vaporize, even at very cold temperatures, because no heat is required. So every suit must provide an internal atmosphere with the right pressure and oxygen mixture to prevent the astronaut's blood from turning into steam. In Earth orbit, the radiation level is about 200 times higher than on the surface. This radiation is a mix of high-energy particles like protons, heavy ions, and electrons that can shred DNA and destroy cells. The spacesuit must shield the astronaut from lethal cosmic and solar radiation. Since heat transfer via convection is impossible in space, insulation and reflection are vital. If part of the suit faces the sun, the temperature can soar past 120 degrees Celsius, around 250 degrees Fahrenheit, while the shaded side can drop to minus 150 degrees Celsius, minus 238 degrees Fahrenheit. A liquid cooling and ventilation garment, or LCVG, must be worn under the main suit to actively control the astronaut's body temperature. Every suit must allow the astronaut to move and work freely. This requires carefully designed joints so that the internal pressure doesn't make bending impossible. Every suit must provide communication facilities, a microphone, speakers, and connection to the spacecraft or the life support unit. Now, this part might not be pleasant for aspiring astronauts, but spacesuits must manage bodily waste, the classy name for urine and feces. This is usually done with an inbuilt urine collection device or by using a maximum absorbency garment, or MAG, which is the high-tech name for something that looks a lot like an adult diaper. Astronauts on a sensitive space mission might have to do both number 1 and even number 2 at the same time. I've finally found the answer to one of life's great mysteries through this video. What does an astronaut do when they need to go outside the spacecraft? There are no trees to hide behind in space, after all. There are also designs to collect and recycle an astronaut's sweat, as spacesuits carry a drinking water supply. So I think my point about recycling body sweat is clear. You get it! I probably shouldn't gross you out any further. You might want to reconsider that astronaut application. Currently, there are 3 main types of spacesuits: IVA, intravehicular activity, for use inside the spacecraft, lighter and with less protection because the environment is already protected; EVA, extravehicular activity, for venturing outside the spacecraft, more complex with a life support system, protection from radiation, pressure, temperature, and micrometeoroids; and EIVA, intra-extra, a hybrid suit that can be used both inside and outside the spacecraft. New astronaut suits incorporate modern systems for oxygen supply, CO2 removal, ventilation, and heat transfer. Unlike in the 1980s, NASA no longer produces spacesuits in-house. Instead, suit contracts have been outsourced to private companies to support both government and commercial missions. Designed by NASA in the 1980s for the space shuttle missions, this suit is still in use today for spacewalks outside the International Space Station, or ISS. The EMU is specifically designed for the microgravity of Earth orbit, suitable only for working in the dust-free, zero-gravity vacuum. Its internal pressure is about 4.3 psi, which is equivalent to 0.3 atmospheres. And on Earth, it weighs approximately 130 kilograms, or about 286 pounds. It includes the PLSS life support system, oxygen ventilation, and a liquid cooling system. The suit's components, arms, legs, and torso, are separable, allowing different astronauts to customize it to their size. The main drawbacks are its bulkiness, difficulty in donning or putting on, and its unsuitability for surface environments with gravity and dust like the Moon or Mars. The shoulder and leg joints also offer limited mobility. This experimental NASA project, developed at the Johnson Space Center from 2012 to 2017, featured 3 conceptual suits: Z1, Z2, and Z3. The primary focus was on lunar and Martian surface missions. A key design feature of the Z series is the hard upper torso, combined with soft sections in the limbs. It also introduced another revolutionary feature, a back entry for docking with a suit port. The second version, the Z2, was produced using 3D printing based on astronaut body scan data. Its internal pressure is 4.3 psi, and it weighs about 65 kilograms, about 143 pounds. The Z3 is still in the planning and prediction stage, with no operational version yet released. Its design differences will aim for improved freedom of movement, reduced weight, upgraded life support systems, better suit port compatibility, and increased customization.
This suit is the result of a collaboration between NASA and Axiom Space for the Artemis 3 program, the return to the moon, and will be worn by NASA astronauts on the lunar surface. The AxEMU is specifically optimized for Artemis missions and surface operations on the moon, which involves low gravity and high dust levels, particularly in the South Pole region. It is ready for extremely cold conditions. Its gloves have been tested in a cold chamber at -213 degrees Celsius, or around -351 degrees Fahrenheit. NASA and Axiom Space developed this suit by drawing on the experience of the Z series. The commercial and updated version of the AxEMU was unveiled in 2023. This suit allows an astronaut to work on the lunar surface for at least 8 hours and can tolerate the extreme cold in the dark parts of the lunar pole for at least 2 hours. The AxEMU includes special coatings to prevent lunar dust accumulation. It represents a significant design leap compared to the 1980s EMU, featuring greater mobility in the legs and knees, lunar dust compatibility, and a back entry design instead of the multi-piece assembly. In other words, the EMU is a single unit that the astronaut enters through a hatch. Its official weight has not been released. The suit features a wider field of view in the helmet, an LED lighting system, and 4K cameras. The shoulder joints are fully rotational, and the elbows and knees are smoother. The new PLSS life support system is lighter and has a longer lifespan, and its modular design is adjustable for various body sizes, fitting both men and women. The suit's internal pressure is approximately 4.3 psi. The demo version was black, but the final version will be white. Lunar surface suits are white to reflect the sun's intense light and heat and prevent the astronaut's body from overheating. The white color also helps lunar dust be seen more easily.
SpaceX recently introduced a new EVA suit, Extravehicular Activity, designed based on their IVA in-flight suits. This suit was developed for the 2023 Polaris Dawn mission. First, let's understand the IVA suits. The SpaceX Dragon flight suit, known as the IVA suit, Intravehicular Activity Suit, is designed for use inside the Crew Dragon spacecraft. Its main purpose is to protect astronauts from depressurization or cabin leaks in case of an accident, not for activities outside the spacecraft. Inside the vehicle, the hull provides protection from radiation and temperature changes, so the IVA suit doesn't need these layers. This suit is light, form-fitting, and flexible, creating a balanced internal pressure. The spacecraft's life support system is connected to it via a cable on the left thigh, supplying oxygen and power. The helmet is a single piece, 3D printed, with an internal microphone and ventilation, and the gloves are designed for use with touchscreens. The minimal design and black and white look were achieved by the SpaceX design team in collaboration with Jose Fernandez, a costume designer for superhero films, making it both functional and aesthetic. The SpaceX EVA suit is essentially an extravehicular version of the Dragon flight suit, with added protective layers, new articulated joints, flame-resistant materials, and an advanced design. It includes a Faraday layer for protection against external electric fields, and its spiral zippers make donning and doffing, putting on and taking off, quicker and simpler. The boots are made of thermal material similar to the interstage section of the Falcon rocket and the Dragon trunk. This suit also holds the record for the first fully independent private EVA spacesuit in history. Its design is for short activities outside the spacecraft in Earth orbit, not for walking on the surface of the Moon or Mars.
The SpaceX EVA suit is lighter than NASA suits, about half the weight of the EMU, and lacks an independent life support system, PLSS. It's connected to the spacecraft via a cable. Its internal pressure is about 4 psi. The helmet features a heads-up display that shows the suit's status, including pressure, temperature, and humidity.
In December 2022, NASA signed a contract with Collins Aerospace to design and develop a next-generation spacesuit system for use on the International Space Station and the low Earth orbit environment. This suit is intended to replace the older suits for maintenance and operations in low orbit. The new Collins Aerospace suit features adjustable sizing so that men and women of different sizes can use it. One of the main design focuses is increased mobility and freedom of movement in the hand, arm, and shoulder joints. Reports indicate that as of mid-2024, the development of this suit has faced delays, and negotiations with NASA have occurred to continue the contract. Thus, it has not yet reached the stage of full operational flight production. The new design features reduced weight and internal volume to boost astronaut efficiency. For example, the weight has been reduced from about 125 kilograms, about 275 pounds, to 90 kilograms, about 198 pounds, and the internal volume is designed to provide easier movement and greater freedom. The suit is designed to fit everyone, from the smallest female astronaut to the largest male astronaut. This suit has an open architecture design, meaning modules can be interchanged or upgraded. More advanced life support systems and fewer components allow for simpler maintenance and shorter astronaut training. The suit has not yet been fully used operationally in orbit and is in the design and prototyping phase.
The spacesuit is not just a white baggy covering. It is a small life station, a spacecraft that you wear. Every module, every system, and every component in these suits is the result of years of experience and meticulous engineering. They are tools for survival and the key to entering other planets. These suits tell the story of engineers who, facing the fear of death in a vacuum, made the dream of inhabiting the Moon and Mars possible. So when we look at astronauts, we don't just see brave individuals, but we also see years of thought, innovation, and the courage of engineers to conquer space. Every generation of spacesuit is a bridge between the past, present, and future of human exploration. A bridge that brings us closer to the dream of setting foot on the Moon, Mars, and beyond. Our world is full of amazing and sometimes incredible stories. If you found this video interesting, please like it and share it with your friends. Be sure to write your comments and questions in the comments section. We'd love to know which part of this story was most interesting or surprising to you. Stay curious until the next video.